Alright, so let's tackle everything you need to know for AP Statistics Unit 1, starting off with the difference between categorical and quantitative data. Quantitative data just deals with numbers, so think quantity, numbers, that's stuff like heights, class size, population size, anything you put a number on. And categorical is stuff that's like names and labels, so think like eye color, hair color, you can't put a number on that. So we're going to branch off here and talk about categorical data, which you want to represent with a two-way table. You've probably seen these before, but basically you have two variables on either side, and it just shows you like the cross or the intersections between certain variables. So you see here, we have math students. Sure, we have 10 math students, but then we also have the internal and external variables that split up the number of math students. So we have 3 math students for internal, 7 students are external, in the same case for English. So the important thing you need to understand is a couple vocab terms that the AP might use in your teachers might use on your midterm is marginal relative frequency. That's a percentage of the data in a single row or column compared to the total. And if you look at this little chart here, that's going to look at B over D or C over D. So we have our column total, which is just going to be C over D, and then our row total is B over D. The next thing we're going to look at is joint relative frequency. So that's a percentage of data in a single group compared to total. So group here that might be a little confusing is just we're going to look at A, right? So that's just a singular variable or intersection that we're going to look at between a certain variable. So that's A over D. And if we look in our two-way table with actual variables, that's something like math internal. So that'd be 3 over 23. Or maybe we want to look at external English. So that's, we look down English, external, so that's 9 over 23. Okay, so next we're going to talk about conditional relative frequencies. That's percentage of data in a single category when you're given a specific group. So now that we're going to be looking at A over B or A over C. Now that's something like just A, right? And then the total in the group or column is just going to be over A over C or A over B. And in our little two-way table, that's going to look like, let's say we're given that the student is in math. So that'd be 10. So our total would be 10. And then we want to know what percentage of that is internal. Well, we have 3. So that'd be 3 over 10 as an example for that part. Okay, so now let's go on to quantitative data. So for quantitative data, you want to know how to describe it. A big part of AP Stat is just interpreting, because a lot of the calculations are pretty straightforward. You have a reference table, you can use your calculator, all that. But you need to know how to interpret. So for quantitative data, use the acronym CSOCS. The C stands for context, shape, or S stands for shape. So is it symmetrical? Is it skewed? Number of peaks? Is it unimodal, bimodal, all that? Look at the outliers, right? Any variable, any numbers or data points that are super out wide compared to the rest of the data. You have your center, right? So look at your mean or your median. You have spread, right? That's just range, your standard deviation, and your IQR. And then here's a little tip when you are describing the data is utilize descriptive language like strongly, roughly, like roughly symmetrical and all that. And also use comparative language to maximize the number of points you can get on the exam. Okay, now let's go on to some basic terms you must know. I mean, you've probably seen these before. Mean, that's just the sum of all the values divided by the number of values, or the average. I mean, that's like the average value. Standard deviation is just a measure of variation. And here's an important part when you're describing it in context, okay? So you want to say like the value / context, it typically varies by standard deviation value from the mean of mean. Okay, that sounds kind of weird, so let's look at the example. The average PrepWorks subscriber's IQ typically varies. So PrepWorks subscriber's IQ is the value / context. Always put it in context. Varies by 5 IQ points. So 5 IQ points varies by 5 IQ points. That's the standard deviation from the mean of 169 IQ points. The median is just the 50th percentile. So that's where if you have data, you organize it from least to greatest and then look at the value in between, right? You probably heard of that. And range is just the value, not the interval, the value of max minus min in your data set. Okay, so the last thing for exploring data in this part is how to make box plots. You need to know the 5-number summary. So the first number in the summary is your minimum. That's just the smallest value you have. Then you have the 25th percentile or Q1. That is just in between your minimum and median, right? It's the exact, it's pretty much like the median of your minimum point and 50th percentile, if that makes sense. And then the next number is your median or 50th percentile. Then is Q3 or your 75th percentile, and then your maximum value. Okay, so the next thing is IQR. IQR is just Q3 minus Q1. And that's important because you also need to be able to describe specific outliers and their characteristics, that being low-end outliers or high-end outliers. So low-end outliers, like the name suggests, is just a super, super low outlier. So that's going to be any value less than Q1 minus 1.5 times the value of QR. And the same thing for high-end outliers. That's a super high outlier. That's any value greater than Q3 plus 1.5 times IQR. So make sure you know those two equations. And here we just have a visual diagram because box plots are cool to draw. All right, so to round off AP Stat Unit 1, we just have a couple more terms and then we'll get into normal distributions. The first is officially defining percentile. We did talk about it, but how I think you should think about it is that it is the percentage of values that are less than or equal to a specific value. And then we also have cumulative relative frequency. So that shows the cumulative percentages from each interval up through all the data. And here we have a visual. So you can see here when we have a data point, that obviously is graphed. But when we don't have any data, that is just a straight plateau. And then when we get data again, oh no, it's bugging. Okay, so if we get data again, then that thing is going to go up because it's pretty much like I would say a running total of the relative frequencies. And relative frequency is just like the chance of something occurring. So that's like the occurrence or frequency over the total. Okay, so now let's talk about z-scores. So z-scores are tying back to the idea of standard deviations. Z-scores are simply the number of standard deviations a value is away from the mean. And this is the official equation for it. It's whatever value you're looking for the z-score for minus the mean over the standard deviation. All right, so now we're going to talk about what happens when you transform data. Okay, so let's say you have a data set. What if you added a certain constant, like you added 5 to every single value, or maybe if you multiplied every value by 20, right? What would happen to the shape, the variability, and also the center? Well, here is a summary of what would happen. So if you added or subtracted all the data values by the same amount, the shape and variability will always stay the same. The center, so that's like your mean or median, will move up or down by that amount. Now, if you multiply or divide, that's a different story. The shape will still stay the same, but now your center and your variability will be multiplied or divided by that amount. All right, so now let's talk about density curves and normal distribution. So a density curve is on or above the horizontal axis, has an area of 1, and just shows probability distribution. Note that a normal distribution is a type of density curve, but no. When you talk about a uniform density curve, it's quite rare. You might see questions on this though, but you can see pretty clearly that it has a total area of 1. But the more common, I guess, density curve you'll see is the normal distribution. You'll 100% see this, and you've probably seen this before. So you need to know pretty much the standard deviation and the 68, 95, 99.7 rule. So 68% of the values from the mean are within 1 standard deviation of the mean, 95% of the values are within 2 standard deviations of the mean, and 99.7% of the values are within 3 standard deviations of the mean. So to solve normal distribution problems, you're just going to use your calculator. I mean, that is the most simple way. So know your calculator commands, go and study those. So norm PDF, that finds a probability at a specific value. Norm CDF, that shows probability that the normally distributed variable is between a set interval, pretty similar to norm PDF. And then we have inverse normal, which pretty much does the reverse of these calculations. It finds the value that corresponds to a given percentile, or on your calculator, it might be denoted as quote unquote area, okay? All right, so the final thing we're gonna talk about is super niche, but I'm still gonna include it because it's on the CED. That's a normal probability plot. So what it does is it plots the actual values versus the theoretical z-values. Okay, so these theoretical z-values are the z-values you would get if the actual data points were normally distributed. Okay, so it pretty much just shows you how well the data fits a normal distribution, and that's something you might see like that. So basically, all you need to know is that if it's roughly linear when you plot this, or it might just give you the graph, it's going to be roughly normal distribution. And if it's not linear, it's roughly not a normal distribution. And yeah, that does it for everything you need to know for AP Statistics Unit 1. So let's cover the AP Stats Unit 2 content, everything you need to know. So correlation, how exactly do you describe scatterplots? You're going to be using the acronym CDOF. So put it in context, direction is it positive or negative, state any outliers, the form, is it linear or nonlinear, and then the strength of that form. Okay, is it strongly linear, is it weakly linear, all that mumbo jumbo. Now tying directly into correlation and describing scatterplots is your R value. Super important. Your R value is your correlation coefficient, and it can range from -1 to 1. The closer it is to -1 or 1, the stronger linear correlation it has. So something like -1 is a perfect negative linear correlation. A positive 1 would be like a perfect positive linear correlation. Here's some more examples. -0.97 would be considered a strong linear correlation. 0 would be no correlation, and something like 0.021 would be a weak linear correlation. A couple things that do not impact your correlation coefficient is changing your units, right? So if you, multiplied everything by 100, does not change your R value. Also, if you switch the X and Y axis, that does not change your R value. Now let's talk about how outliers affect your R value. So any outliers that are within the pattern of data will strengthen R. Any outliers outside the pattern of data will weaken R. What is the pattern of data? Well, I drew a nice diagram to represent it. So it's basically like the general trend that your points are facing. So this is like our general trend. So if I had a super outlier, like this star I'm drawing out here, that'd be within the pattern of data and strengthen R. But if we had something down here, right, that's outside the pattern of data, that would weaken R. Also remember, correlation does not equal causation. Super important here. You probably heard it before, so just keep that in the back of your mind. All right, so now let's talk about regression lines. So regression lines are essentially just your best fit lines. So if you have a scatter plot with points, you put your best fit line on there, and it helps you estimate values for points that you aren't given, okay? So what this looks like on the equation is y hat. You use y hat instead of y because it is your predicted value, not your actual y value. So it's y hat equals a plus bx. You've seen that form before. A is your constant, b is your slope. Something you probably haven't seen before is your residual. Okay, so your residual is just the degree of error of regression line prediction. Okay, so let's say my actual value is 5 and the predicted value is 10. Then you get -5 as the -5 units as the residual. So that's a negative residual. And negative residuals, that means you overestimated, right? You overestimated by 5 in that case. A positive residual would mean that you underestimated the actual value. All right, so the important thing with, I would say, regression lines is that, yes, you are going to be calculating and extrapolating some values and all that, but I would say the big part is interpreting the regression line with proper language. This is super important. It's probably what's going to be tested on the AP, maybe on your midterm. All right, so here's an example. I just stole this methodology off my AP Stat teacher, so hopefully it's not like copyright infringement, but it basically shows you the one way you could use language to interpret the slope, interpret the y-intercept, interpret the residuals, all that, talking about stuff like explanatory variable, that's just the independent variable, your response variable, your dependent variable, and then using that specific and really correct language. And now let's talk about the least squares regression line. So basically you'll get a big data set and you're going to plug it into your graphing calculator, and then you can use the calculator function to produce the least squares regression line. It's the line that minimizes the sum of the square residuals. You don't need to know what that means, but basically it's like pretty much a best fit line, sort of. So the key things you need to know about this is that you can also find these values, by the way, with your calculator. The S value is your average distance. The predicted values are away from the LSR. And then your R squared value is the coefficient of determination. That's a percent of your response variables that can be explained with the explanatory variable. And for a optimal least squares regression line, you want as low of an S value as possible and as high of an R squared value as possible. Also, sometimes on the AP, you're going to see, I would say sometimes, you're going to see this, the computer printout. Okay, it's kind of weird, I know, but you might have not done this in class. There's just something to keep note of is just these like computer printouts. This is a nice graphic. It shows you where the y-intercept, the slope, S value, R squared value, yada, yada, yada. You'll learn these other things like TMP and liter units, but basically, yeah, just like memorize these values, where they are and all, just so that if it shows up, you aren't just caught, not knowing what to do. Okay, so let's talk about outliers. Okay, so how do outliers affect your least squares regression line? Any outlier, okay, is going to decrease your correlation. Now, here's the thing, right? Outliers are added far away from the mean of y, so that's going to be a horizontal line. That's going to decrease your slope and also increase your y-intercept. And the outliers are added above the mean of x, so this case is a vertical line. Your slope stays the same, your y-intercept decreases, and if it is added below the mean of x of that vertical line, then your slope is going to be the same, and your y-intercept is going to increase in this case instead of decreasing. So the last thing we're going to cover now is residual plot. So it pretty much just plots residual values versus the explanatory or independent variable. If there's a clear pattern, that means a linear function is unlikely to be the best fit for the data. If it's an unclear pattern, that means a linear function is likely to be the best fit for the data. And here is a example of an unclear pattern. You can see it's just like pretty much random dots. So in this case, a linear function would be likely. Something like a clear pattern would be like, I don't know, I'm just going to draw something random. Let's say this was the line. And you go something like this, right? Like a U-shaped parabola, whatever. That means it would be unlikely for a linear function to be best fit for that data. So that does it for all the content you need to know for AP Stat Unit 2. All right, so today we're going to cover all the content you need to know for AP Statistics Unit 3. Okay, so the first thing we're going to talk about are sampling methods. Okay, so the most common one you're going to see is simple random sample, or SRS. It's a random selected subset of the population, and all members in the sample have an equal chance of being selected. And here's the general process you would typically use when doing a simple random sample. You're going to define the population and label the individuals. So what that actually looks like in practice is you're assigning numbers to people, or you're putting their names on a slip of paper. And then number 2 is you have to randomize, okay? That's why it's called a random sample. So you can do randomization through a random number generator, put people's names in hats, whatever. And number 3 is just select members of the sample for your simple random sample. So the next sampling process we're going to talk about is stratified random sample, where you're going to split the population into groups or strata based on shared traits, okay? These are basically shared traits as in like homogeneous groups, okay? You have groups where they share a certain trait. So let's say I had PrepWorks subscribers, okay? I split you guys into PrepWorks subscribers and PrepWorks not subscribers, okay? And then what you're going to do from there is randomly select samples from each group. So if I had 10 PrepWorks subscribers and 10 PrepWorks not subscribers, I'd randomly select, say, 2 people from each group, where everyone in that group has equal chance of being selected. So here's another example. You divide a school by grade level and then randomly pick students from each grade. Now, the confusing part with stratified random sample is there's a very, very particular close second to it, is a cluster sample. Okay, it sounds very similar. You're splitting the population into groups/clusters and then randomly selecting entire clusters. I made that bold for a reason, okay? I made that capital letters for a reason. Entire clusters to sample. So example of that is splitting a city into neighborhoods and surveying everyone in a few randomly chosen neighborhoods, okay? So here's a diagram to make sure that is depicted nicely. So for a stratified random sample, I split it into red people and blue people, right? And then within the red people, I do a simple random sample. And then within the blue people, I do a simple random sample. But for cluster sampling, what I do is my groups, instead of having homogeneous traits, right? My stratified random sample is either you were red or you were blue. But in cluster sampling, I want equal heterogeneous, like equal representation essentially, right? So basically I have like, some red people, some blue people, yada, yada, yada. And then when I pick who to survey, I'm picking entire clusters. So I pick a random cluster and then I sample everybody in that cluster, okay? The next sampling technique we're going to talk about is systematic random sample. That's where you select individuals at regular or set intervals and you start at a random point. So for example, if I was like sitting outside of my school or something, and every 5th person that walked in, I would give them a survey, right? That's systematic random sample. All right, so we're going to talk about some bad sampling methods. Convenience sample is where you basically choose people who are like easy to reach, easy to access. Example of that is surveying people at a nearby mall only because it's close to you. And the other bad sampling method, there's tons, but these are the most common, is voluntary response sampling. So you allow people to choose to participate. Let's say you put like an online poll, right? Let's say you have like a TV show or something, and then you're like, hey, you should answer this online poll about, said issue. Well, people who feel strongly about that issue are more likely to respond. You're giving them the choice, right? So that introduces bias, and that's why it's a bad sampling method. Here are a couple more shortcomings. Number 1 is undercoverage. So when some groups are left out or underrepresented in the sample. So for example, if you send a survey only to people with internet access, then people who don't have access to the internet can't give their opinion, and therefore that is undercoverage. Non-response is when your selected individuals don't or can't respond. So for example, if you call somebody and you're like, hey, can you do the survey, yada, 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 and they say no, well, that's non-response bias and shortcoming as well. Next up, we have response bias, when people give false or misleading answers. So this is like the equivalent of lying. Now, sometimes it can just be about lying, right? But it's not like explicitly them trying to lie, but it's just that their answers are prone to some sort of bias. Let's say you had, let's say you were reviewing our YouTube channel, right? But let's say you are a friend of me, right? So like you know me in person. Well, then you're going to be having response bias because you know me in person and yada, 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 okay? I think you get the point. Next up is wording in the question. So if you poorly phrase the question or it's a biased question, it influences the answers. So if I ask you, do you want to subscribe to PrepWorks Education? That might be a good question on its own. But if I say, do you want to subscribe to PrepWorks Education to receive $1 million? There's a little bribe at the end, right? So the wording in the question there is poorly phrased, it's biased, and it influences your answer. Okay, so now let's talk about observational studies and experiments. So an observational study is different from an experiment because in an observational study, you only observe and collect the data without influencing the subjects. Okay, so for example, if you just sit in your car and then you watch other people in their car and you see how many people use seatbelts in their car, you can't do anything about them, right? You're just simply sitting there and observing variables of interest. The observational study is the direct opposite of the experiment. Now, why? Well, because in an experiment, you are manipulating variables or applying treatments to observe and measure the effects on the subjects, right? And when you conduct an experiment, you want to follow 4 principles. And when you are answering questions, make sure each of these principles are clear in your explanations for full credit. Comparison. You want to compare 2 or more groups to see the difference in the treatment. Random assignment, just randomly assigning subjects to groups to reduce bias. You can also be randomly assigning treatments. Control, so you have to keep all variables constant. You've probably heard this before. Replication, make sure you have enough subjects. So don't just do an experiment with 2 people. Do it with a sufficient number, respectable amount. A couple more key vocab terms is factor. So factor is the explanatory variable or independent variable. It's just a term used when there are multiple independent variables. Level is just a specific value or category of the factor. So it could be like sunlight is a factor, but then it could be like low sunlight is like level or high sunlight. Confounding is when another variable affects the results. So like if you don't properly have a control group, then it's hard to determine the true cause of your results or your treatment. Placebo is a fake treatment where participants may react favorably to it. Single blind is when the subjects don't know which group they're in, so the treatment being assigned, but the researchers do. Double blind is when neither the subjects or researchers know who gets what treatment or who's assigned to what group. So we're going to finish off with the randomized block design. So a randomized block design is a specific type of experimental design where subjects are divided into blocks or groups based on specific characteristics. So it's kind of like the stratified random sample. And each block is randomly assigned a treatment. And a block is just a group with experimental units with the same characteristic. So here we have a similar study population. So let's say our study population is PrepWorks viewers viewing this video right now. And so we're going to split them into 2 blocks. Okay, we have block 1 is PrepWorks subscribers because they all have the same characteristic, right? They're all subscribed to the channel. And then we have another group or another block is not subscribers. They have the same characteristic. They're not subscribed to our channel. And then from here to actually conduct the experiment with the randomized block design to properly do it, we need to assign treatments, right? So I don't know what experiment we're running, but to assign the treatments, we need to randomly assign the treatments. And we can do that with, random number generator, names in a hat, whatever. All right, so the last experimental design type we're going to talk about is matched pairs design. Okay, this is a specific type of experimental design where your subjects are paired based on specific characteristics, and each pair is randomly assigned a treatment, or one subject in each pair could be a control. So example of this is think about, let's say you're doing an experiment and then you want to sort of like eliminate bias based on gender. Then you can pair like a male with a female, and then have one of them be the control group or just randomly assign the treatments between them. So yeah, that was a lot of vocab and not a lot of, crunching numbers and stats. I know it's weird. There's a lot of interpretation here. Make sure you really know these vocab terms because that serves as the basis of your interpretation and designing your own experiments and, interpreting, is this a bad sampling method and all that. But yeah, that does it for all the content you need to know for AP Statistics Unit 3. I'm going to cover everything you know for AP Statistics Unit 4, which is going to cover topics on probability and also random variables. Do you see this? There's a lot of content, so let's just get right into it. So what is probability? Well, it's the chance that something happens, and it's written as 0 to 1. So if it's 0, it's impossible. 1 means 100% chance of happening. It's unpredictable in the short term and predictable in the long term because you have to observe many, many trials of the same proportion of the random chance process before it actually starts to approach its actual probability value. So let's say my chance of making a free throw is 50%, right? So if I shot 10 shots, it's likely that I only make 5, but I might make 4, or I might make 6. But if I shot 1,000 free throws, it's much more likely because of the many, many more trials that I actually have a proportion equal to 0.5. So for simulation, it is just a model used to mimic real-world events to estimate probabilities. You can use a 4-step process to conduct a simulation. You're going to define the problem with the question. Then you're going to describe how to use a chance process like random numbers to model the situation. And then you're going to actually perform that. And then based on your results, you're going to estimate the probability. Now we're going to talk about probability rules. To talk about probability rules, we first need to get a couple definitions out of the way. The first one is mutually exclusive, okay? 2 events have no overlap and cannot occur at the same time is the definition for a mutually exclusive occurrence. So you can see here, this is a nice diagram. You have event A and event B, right? They're mutually exclusive because there's no overlap, right? They cannot occur at the same time. But if they're not mutually exclusive, they can occur at the same time. That's why there's the overlap in the Venn diagram. The next one is independence. So 2 events are independent if the outcome of one does not affect the outcome of the other. So for example, if I flip a coin and I roll a die, the result of one does not change the result of other. If I flip a coin, right, whatever I get, head, tails, whatever, me rolling a die, because I flipped a head or because I flipped a tails, that doesn't change what I'm going to get or the probability of what I'm going to get on the die. All right, so probability rules. So let's say I have 2 possible events and their probability of occurring is probability of event A and probability of event B. How would I find the probability of either one occurring? So it doesn't matter if it's probability of A happening or probability of B happening. If these 2 events were not mutually exclusive or if both of these events could happen at the same time, I would add the probabilities and then subtract the overlap. If they were mutually exclusive or they cannot happen at the same time, I would simply add their probabilities. And these equations are on the reference sheet. The top one is, not the mutually exclusive one, so just make sure you remember that. So now, what if I wanted to find the probability of both event A and B occurring at the same time? Well, if they were not independent, you would just multiply the probability of A with the probability of B given A. If they were independent, you would just simply multiply them. And these equations are also given on the reference table. But now let's talk about the complement rule. Okay, so that's cool and all, but what is the probability that A does not occur? Well, the probability of A not occurring is just 1 minus the probability of A. That's given as a complement rule on your reference table as well. Actually, I'm not sure if this one's on your reference table, or reference sheet, so make sure you check that one. But we're going to move on to visualizing probability in 3 ways. So there's the Venn diagram, which obviously shows the chance of something happening, event A and event B, and then their overlap. And you have a 2-way table. You've probably seen this back in Unit 1, just displaying the data. And then you also have a probability tree. The thing with this is I do have an example for this, but I would say that visualizing the data is really coming down to just personal interpretation. So if you are a little confused, pause the video here. I do run through an example here as I scroll down that sort of explains how to interpret the data. But if you are comfortable with the 2-way table and the Venn diagrams and understand how we're getting these probabilities, if you're trying to brute force it, it's very difficult and it's very hard to visualize. But I'm telling you, just tie it back to the probability rules, okay? like my entire explanation over here is just using probability rules, and then I'm tying that back into what I see on the Venn diagram, a two-way table, and then if you want an easier visual, look at the probability tree as well. So let's move on to the random variables. So we have 4 types: discrete, continuous, binomial, and geometric. Okay, so your discrete random variable is a random variable that takes on a specific countable values. So think of like the number of heads that you flip in 3, the number of cars sold by a dealer in a day. So it's like quantitative numbers. Now, when you have a continuous random variable, that means it's any value within a range or interval, right? So it's not just 1, 2, 3. You actually count what's in between 1 and 2, right? It's continuous. It's everything in between as well. So think about the height of students in a class, right? So if you think about heights, it's not just you can be 1 inch or 2 inches. Obviously, that's super short, but you can be everything in between, right? Also, the time it takes to finish a race, right? It's incremental. It's not just finishing a race in 1 second or 2 seconds. It's also, you can be like 1.1111. You get the point, right? And here is another diagram just to show the difference between discrete and continuous variables. All right, so if you want to find the mean and standard deviation of discrete or continuous variables, you can also use one variable statistics on your calculator. And a common calculation you will probably have to show for a discrete random variable is calculating the mean or expected value / weighted average. It is the average value over many repetitions of the same chance process for this discrete random variable. Here's an example. You can see x basically just describes the value of that discrete random variable, and then p of x is just the probability of each of those variables. And so what you would do is quite literally just multiply across 1 times 0.1, 2 times 0.3, all the way to the end. And then whatever you get, you add everything, and that is your mean, weighted average, expected value. So now obviously we have to talk about, can't be stats without talking about how you transform probability distributions. So here's a summary. If you add or subtract the same constant c to each data set, the shape unchanged, center increases or decreases by c, variability remains unchanged. If you multiply or divide by the same constant c to each value in the data set, your shape stays the same, center multiply or divide by c, and variability multiply or divide by c. All right, so here are a couple more equations you need to know when you are adding or subtracting sets of data for random variables, assuming that event A and X are independent events. So you see we have the equation for finding the mean and median of x plus y and x minus y respectively. So make sure you have these equations down. All right, so now we're going to move on to binomial random variables, and I'm going to tell you this is all you need. Okay, you need to know the acronym BINS. Okay, first off, is it binary? Does it satisfy the binary? There has to be a success and there has to be a failure. Are the trials independent? Is there a fixed number of trials? And is there a set probability of success for each trial? So make sure for questions, you address each part of BINS, B-I-N-S, explicitly and show that the events satisfy the binomial settings to prove that it's actually a binomial random variable. For the mean and standard deviation, these are on your reference sheet. We have the mean and the median, not the median. The standard deviation where n equals the number of trials and p equals the probability of success. And I would say you can always abuse the calculator for these problems as well if you're asked about binomial random variables. So here are the calculator commands. You got binomial PDF, that's just NPX. So n is the number of trials, p is the probability of success, x is the number of successes, and it calculates the probability of exactly k number of successes in n trials. Honestly, it should be x number of trials. I'm just change that. Oops. X number of trials. Okay, binomial CDF, NP lower and upper bound. It's like the same thing, except it's the cumulative probability of having k or fewer or more successes in n number of trials. It really depends on the parameters that you put for the lower or upper bound. So yeah. Now we're going to move on to geometric random variables. So these are a type of discrete random variables that model the number of trials required to achieve the first success. It's highlighted, it's bolded, the chance to achieve the first success in a series of independent trials with 2 possible outcomes, success or failure. So very similar to the binomial random variables. So example of this is you're flipping a coin and you're trying to see the number of flips it required to get the first heads. That is the example of a geometric random variable. Here are a couple criteria. The trials have to be independent. Each trial has to have the same probability of success denoted by P, and the random variable counts the number of trials until the first success occurs, like we talked about before in the definition. Now, easy way to tell geometric random variables from binomial random variables is the following. Binomial random variables have fixed number of trials. Geometrics do not have a fixed number of trials, so look out for the keyword until. More calculator abuse and commands, geometric PDF and geometric CDF. If there's one thing you learned today is learn how to use calculator commands because it makes your life pretty darn easy. And then for the mean and standard deviation of geometric random variables, we have the mean is just 1 over the probability, chance of success, and then standard deviation is square root 1 minus probability of success over probability of success. So that does it for all the content you need to know for Unit 4, probability and random variables.